7-1, day 2. Unfortunately, my computer really didn't cooperate when I was putting these fractions in there. It didn't quite give it the way I wanted it to. So let's make it very clear what I want these to say. This first one, so make this actually bigger on your paper. This is supposed to say 1/2 divided by 2. So actually make that line a little bigger on yours. And then this other one's supposed to be 2/3 divided by 3. Okay. I probably don't have to cover this as much as I have in the past because we work on this so much already, but I want to make sure before we go on to the trig ones that we know just the basic idea. So this is really saying 1/2 divided by 2. So if you want to, what you can do is you could look at it as dividing by 2 is the same as multiplying by 1/2. That you could look at it that way if you want. But here's why it's the same as multiplying by 1/2. We've done this a lot. So it's 2 really over 1 if you wanted to make it a fraction over fraction, right? And then when it's a fraction over a fraction, you were taught, or when it's a fraction divided by a fraction, you were taught to invert and multiply, right? But remember, the real reason that works is because you're actually multiplying by the only thing you can multiply by here, which is 1. Okay? And the form of 1 we choose to multiply by is 1/2 over 1/2. Do you happen to remember why we choose a half? What cancels? Yeah, look at this denominator down here. What they said is the denominator all cancels out. So that 2 cancels with that 1 cancels with that. So see how the denominator goes away if I multiply by a half. And so now I have to multiply the top by it. So it's 1 times 1 is 1. 2 times 2 is 4. So it ends up being 1/4. But let's think about that. 1/2 divided by 2 is, well, 1/4. That actually makes sense. But I'm trying to get you to the math of why that actually works out. So okay, there's no equal sign here, so I can't do much else but multiply by 1. That's about all I can do. Okay. So here, you could look at, if you want to look at it as a fraction over fraction, you could do 2/3 divided by 3 over 1. Or again, dividing by 3 is the same as multiplying by 1/3. Okay, but again, here's why that works out. We're actually multiplying by 1. Okay, but again, the 1/3 on the bottom, just like it did before, cancels the denominator. And how about these 3's? Do those 3's cancel where they're at? No, they're both in the denominators. They don't cancel, right? But we can multiply, so we would do 2 times 1 is 2, 3 times 3 is 9, and there you go. So yeah, the computer really didn't quite put that out there the way I wanted to, but I think we get the idea. Once we know where the division actually is, I think we're okay. Any questions on those two? Well, let's alter it, and let's go with some trig. So we're going to simplify each of the following. All right. Well, I see a secant and a tangent in this first one. But remember, there's no equal sign here, right? So there's a lot of things I can't do. I can multiply by 1, I can do that. Or I can switch the identities. Let's face it, are secant and tangent our most favorite trig functions? Probably not. If we had to pick 2 favorites, again, I made you pick 2 favorites because I'm sure that you don't like any of them. But if I made you pick 2 favorites, it'd probably be sine and cosine. Right? So why don't we take all the sines and cosines and see what happens? Okay? So let's use the identities that you got yesterday. What is secant? What does that actually turn into? Okay, that's again why I had you take out your notes. So hopefully those listening to the recording, if you don't have your notes out yet, please get out day 1 notes that have your identities on it. So secant of x would be 1 over cosine of x, that same angle, right? Okay, divided by, again, here's the division, right, the actual division. And then tangent, well, we could write it as lots of things, but probably the best thing to do would be sine over cosine. Right? Again, sine of x over cosine of x. So hopefully now you can see why we spent so much time on that other stuff, just a second ago. Okay. So any questions how I transitioned it? So now what we're going to do, we did the identities. Let's go ahead and multiply by 1. So this time it's actually going to be cosine of x over sine of x, because now my entire denominator gone. All right, this one's cosine of x over sine of x. Again, the important part is that these two cancel. Really, they become 1s. These become 1s, so my whole denominator is now 1. Now, previously, when we went to multiply, we kind of just multiplied straight across, right? And we got something. But what very nicely happens on this one? It doesn't always happen, but what cancels? Yeah, the cosines cancel. It's not always going to happen, but if it's going to, we'll let it. If those are going to cancel, let's go ahead. Yeah, those are 1s. So now we got this 1 times that 1, and that's 1. And this 1 times sine, which is sine. Well, that's way simpler than what we started with. And we're way more comfortable with sine. There is one other way you could write this answer. Using your identity again. 1 over sine is cosecant. I would probably stick with the 1 over sine because we're just more comfortable with it. Now you might be wondering, well, why would you want to do that? Well, what if you didn't have that trig table I gave you and I said, put 60 degrees in for x? Would you rather put 60 degrees in there, figure that out, put 60 degrees in there, figure that out, if I didn't have your table? Or would you rather just put 60 degrees right there and figure it out? Right? The second one, right? Or think of it this way. What if we go on to calculus? Do you want to do something that has 2 functions involved, or would you rather have it just has 1 function involved? Trust me, you'd rather have just 1. Okay, it just makes it easier. Okay? So it actually has become simpler. Right? Well, how about this next one? We got cosine. We're happy with cosine. How about secant, though? Well, what I'm going to do, if there are no questions, I'm going to pause the recording and give you a chance to try this one on your own and see what you come up with. Okay? So those listening to the recording, please also pause it. Don't just wait for the answer. All right. In all honesty, I was a little worried. You did a really good job. I kind of figured you would get to it. I was a little worried how you were going to write it. And you did a great job. It's been written 2 different ways in class that I saw here, and both ways are fine. All right? Because this is something we have to talk about anyways. So what I saw on a lot of the papers as I went around is a lot of people just kind of left it as cosine. They were okay with that. I'm going to leave some space here just a second. And then people wrote this as 1 over cosine. If you really want it to be a fraction over fraction, you can do that over 1. If you're comfortable without it, you don't need it. Right? It's totally up to you on that one. And so now we go with our form of 1. There we go. So this is what I saw on a lot of papers. Whoops. Well, I didn't save that very well, but there you go. So these all cancel. 1 times 1 on the bottom is just 1. Cosine times cosine. Okay. Okay. And so here's what I saw a lot, which is just fine. Okay, because it is taking cosine times cosine. That's fine. Another way that we actually write it is another way that I saw. That. Now, on the graphing calculator, though, remember when you hit cosine, it gives you that parenthesis right away, right? So you have to pretty much type cosine squared that way in the graphing calculator. Okay. Now, here's what somebody wrote 5th hour. I think they meant this top one over here, but that's actually not what that one says. This one says take x and square it, and then take cosine, which is not what we want. Okay, this is not what that one should say. Okay, and I don't think I saw that. So good job. I saw both of these over here on your papers. So any questions so far? No? All right. So here's what I'm going to do. I'm going to give you 3 suggestions of things you can do. We've already done 2 of them. 3 suggestions of things you can do, and then I'm going to give you 3 things that you should not do when simplifying. All right? So 3 things that you can do when simplifying. And I actually try and do them in this order, 1, 2, 3. Right? Number 1 thing you can try and do when simplifying is factor. And I actually found it helpful last year if we just kind of list the factoring types again, because some people have forgotten some of them. All right? So what is a type of factoring? You can just write it off to the side. Any type of factoring that you remember. Yep. Not quite, well, we could use, well, no. We probably won't use quadratic, but we could, like if it was squared, we could, yeah. Key number, yeah. Key number is one of them, okay, that we use. Yeah. Grouping, good one. Grouping's used typically inside of key number, but it can be used on its own. Remember, if you have an even number of terms, you put the little squiggle in and see what happens, right? There's two other ones. The key number happens quite a bit. There's two other ones that happen quite a bit in what we're going to be doing. So any other ideas? Very good. Difference of squares. Again, these are all difference of types of factoring. And this is one that, I'll be honest, might actually happen the most. And it's the last type, and it's the easiest one to forget. I think they know. There it is. Greatest. You were close. Greatest common factor. Yep. That's if all the terms have something in common. You factor it all out of all of them. Okay? And I'd say the two on the left happen the most. The two on the right do happen. Okay? I look for factoring first. Not all of them are gonna. But let's face it, if they do, it normally helps. Okay? Not a guarantee, but it normally helps. So that's number one thing I would look to do when simplifying an expression. You can do that. All right, number two. Okay, number one we haven't done yet today, right? We haven't factored anything yet today. Okay. Number two, we've done this one many, many times already. Multiply by any form of 1. But we want to be picky on the form of 1 we choose. We don't want to make it worse. Like some of the ones we had today, would we 1/2 over 1/2, cosine over cosine? You know, we've multiplied by many forms already today. And this last one we've already done today. But I just have you a list so that you don't forget them. Substitute using the identities from, day one. The quotient ones, the reciprocal ones. And probably the newest ones were the Pythagorean ones, right? Of the Pythagorean identities, I really want you to know the first one. Sine squared plus cosine squared equals 1. The other two, if you ever see a tangent squared or a cosecant squared or something in a 1, maybe think about those and look them up. Right? You can look at your notes and figure it out. But the one thing I showed them in the other class is, and you don't necessarily have to write this one down, just remember this, is that's an identity, right? So if anywhere I see sine squared plus cosine squared, I can completely replace it with 1. Okay? Keep in mind, you're going to be getting expressions which will not have equal signs in them. Just because the identity has an equal sign doesn't mean it materialized in your problem. Okay? But what you can also do is use any algebraic manipulation of that identity. You realize really saying the same thing. I just subtracted cosine squared from both sides. Right? So it's the same thing. So if anywhere I see 1 minus cosine squared, I can replace it with sine squared if I think it's helpful. It all depends on if I think it's helpful, though. Or any of those other ones, you can use any manipulation of it. Okay? Everybody thinks it has to be just like this. Perfect. Well, no. Any part of it, any way you can change that, and it'll still work. So do we agree? These are the 3 things that you can do when you have an expression that you're trying to simplify. Here are 3 things you should not do. And I'll be honest with you, they irritate me in progression here when I see people trying to do it. So you don't have a 1, 2, 3 written down, but you do have this line written, right? Where it says, on the other hand, we cannot do things that require both sides of an equation, right? So right underneath that, right, these 3, they're very short. Okay? Does everybody see where that is in your notes? You got it? These are the no-nos, because you don't have an equal sign, right? You cannot multiply or divide both sides by something, because you don't have 2 sides. Well, that's kind of small. Can everybody read that? Pretty good? I've seen people do that. It's a little irritating. Right? The next thing that some people try, and it's kind of irritating as well, is they try and add or subtract something from both sides. And this one, people try a lot, and really gets me steaming a little bit. Anybody think they know? No? square or square root both sides. If you don't have two sides, you cannot do these things. But the things you can do, we did earlier. You can factor. You can multiply by 1. You can replace the identities. Okay? We can do that. Okay? These are the 3 no-nos. So, of course, 5th hour, I said, what do you think we should do? Well, there's a square. Let's take the square root. They were joking, right? But do you see what I mean? Is that an impulse that you have there? You see the square. You want to take the square root, don't you? But there's no equal sign. You can't do it to both sides. All right? Not going to work. Okay? I can't subtract the sine squared over to the other side. There isn't one. Okay? So let's go through the progressions of the things we can do. Number 1 I like to look for is factor. We have 2 terms. We have the red term and the green term. Do the red and green term. There's only 2 of them, so we're not going to key number factor. It is not a difference of 2 squares because it's addition, right? The difference means subtraction, so it's not that. It's not grouping because we can't put the little squiggle in the middle. The only other type of factoring we could have is the one that's going to happen the most, which is greatest common factor. Do those 2 terms have something in common? Yeah, sine a little bit more. Sine. Yeah, they have sine squared. Right? Both of them have sine squared, so let's factor it out. All right, greatest common factor, so sine squared of x. So in parentheses, what I have to do is put what would remain from all of that if I took sine squared out. Very good. I saw somebody. A lot of people forget this, is that. Okay, and I'm going to explain why that's there. Basically, if I take sine squared and I factor out sine squared, I have to have that 1 left so that when I distribute it back in, I get the sine squared again, right? So what do I have to, what does this turn into then? Well, if you take the sine squared out, it turns into, and again, look, if I distribute this back in, I do get back to where I started, right? So this is how you always check that. So that's good factoring. Okay, so that helps. And typically what I'm going to do is I'm going to give you problems that you can get down to 1 trig function so that you know what your goal is. Otherwise, you're like, what's my goal here? Like, what am I trying to get to? We're trying to get something that would take us less time to plug values in or do calculus to and things like that. Okay, so 1 trig function. Well, no, we still have 2. We have sine squared and we have tangent and, oh boy. Any thoughts? Well, we did factoring, right? Any more factoring we can do? I don't see any, right? We could do something more if that was a minus. Right? That'd be difference of 2 squares, but it's not a minus, it's a plus. Okay. So I think the factoring's kind of done. Multiplying by 1, I normally save. That's the second option, right? I save if there's division involved. Multiplying by 1, there isn't really. Okay. A variety of things we could do right now. Obviously, one way is faster than the rest. Here's what I see. I see a tangent squared. I also see a 1. Alarms should be going off in your head. Not alarms that say take the square root. Okay? Alarms that say, oh, that might be one of my Pythagorean identities. Right? So take a look at your sheet from yesterday, and do you have anything that has tangent squared involved as an identity? Okay, I think it's the second one, isn't it? And does it rate it as tangent squared plus 1? Is that how it rates it? Okay. So tangent, this is the identity, the second one on your sheet. Like that, right? I'll be honest with you, anytime you can get rid of a plus or a minus or something like that is a good thing to get rid of. So it's saying anywhere I see a tangent squared of x plus 1, I can replace it with secant squared. So this I can replace with secant squared if we want to. I think that seems like a pretty good option. Right? Let's do that. Let's replace it. So I'm going to take that and I'm going to bring that right in here. So we got sine squared. This is still out there. Right? This is still just right here. And I'm going to turn this whole thing into secant squared. This is weird. I told you could get it to 1 trig function. We still have 2. Any ideas? This one I can see that maybe you would not. Okay, watch this little maneuver. Think you know? Close. But we're actually going to have sine squared over cosine squared is what we're going to end up with. All right, watch what happens here. Secant of x is, do we agree, is 1 over cosine? Right? This is the identity. Does this have an equal sign? Can I mess with this with all those other things? Yes, I can. This has an equal sign. It doesn't make one over here, okay? It doesn't just like magically appear over here now, okay? But I can do anything I want to this. So I could square this side, and I could square that side. This is secant squared of x. Well, what's 1 squared is 1 over cosine squared. Okay, so secant squared is 1 over cosine squared. Secant to the 5th is 1 over cosine to the 5th. It all stays the same. So I'm going to replace that then. Secant squared is 1 over cosine squared. And the only reason I would choose to do that is, well, you know, secant isn't exactly one of our best friends. Still not one trig function, but I think the one student who I will not name because, you know, don't want to get in trouble or anything. You know. I could write that as secant squared over 1. So now you take secant squared times 1 is secant, or sine squared, excuse me. Sine squared times 1 is sine squared. 1 times cosine squared is cosine squared. What is sine squared over cosine squared? Tangent squared. Do you need to see me off to the side do that again? It's really just the identity squared both sides, right? This is just tangent squared. So isn't that crazy that all of that up there just becomes tangent squared? So then somebody's like, well, how come I didn't just go up and just cross off the sign and we would have had the answer? Yeah, that's always going to work. Like, I would go through all of this if that was always going to work. All right? So once again, do you want to do, if I gave you an angle right now, would you rather plug it in at the end or plug it in at the beginning? I think we'd rather work with it at that final one. Okay? And I'm not trying to say this is easy, but I am trying to tell you, normally I'm going to give it to you, you can get it down to one trig function so you know where you're going. Otherwise, it's blind. You're just like plugging stuff in, right? All right, let's try one more. Once again, this can get down to one trig function. What's the first option? What should we always look for first? Factoring. Well, once again, there's only 2 terms. How'd that feel? All right. Those listening to the recording, don't worry about it. Somebody just bashed their knee into their desk. It's okay. All right. So there is subtraction. So could it be difference of 2 squares? Well, it's a difference, not of 2 squares, right? So no factoring there. Key number requires 3 terms. Grouping requires, you know, like 4, 6 terms to put the squiggle in. How about greatest common factor? Do they have anything in common? No. Well, factoring is a wash on this one. Got nothing. So what's the second thing we should try? Yeah, multiply by 1. Normally I only do that with division, though. There's not really any division right now. So our last thing is going to trig identities. So do you see any Pythagorean ones? Do you see anything squared? No. So it's probably not a Pythagorean. Let's just go to sines and cosines then and see what happens. All right? We're more comfortable with them. So this turns into 1 over sine. This is cosine of x over 1 times, now cotangent, you might need to look that one up if you don't remember it. We could write it as 1 over tangent, but then we're not all in sines and cosines, right? So cotangent, that'd be tangent. So, yep, cosine over sine, yep. So once again, we started kind of with 2 terms. We started with a red, and we'll go black this time. So here's our red term. It's turned into that. And our black term is turned into that, right? If we're color coding it. We still have that minus, right? How are we going to get to one term, one trig function, when there's a minus? Well, that's kind of hard. what I found is students don't notice that these two fractions have a common denominator. The denominator is sine on both of them. I have seen some very strange things in the past. Students do fine with common denominator when it's a number. When it starts turning into a function, they start doing some really weird algebra. Like some people think the signs just go away now. Well, no, when you're subtracting or adding fractions, the common denominator just stays, correct? That's my denominator, right? What's the numerator? Well, there's a 1 minus, right here. Well, what's cosine times cosine? We did that just earlier, didn't we? That's cosine. Is everybody okay with me writing it there, the square? Do you understand that's kind of where it goes? We're just lazy and we write it that way. Well, still not one trig function. Don't like the minus. It's going to make it hard to get to one trig function. Any thoughts? We could try multiplying by 1. Yeah, that could be an option. We would do what? We'd have to multiply by 1 over... Yeah, it wouldn't get us anywhere because we'd have to multiply by 1 over sine over 1 over sine. The bottom would cancel, but then we would still have it end up over sine. It was a good idea, though. It's a good try. I see a trig function squared and a 1. You should probably be thinking of Pythagorean identities. They may or may not help, but you should probably think of them. Do any of them specifically say 1 minus cosine squared? No. Do any of them have a 1 and a cosine squared in them? Yeah, which one? The first one? So the first one, well, that's really bad too, but anyways. The first one says that, correct? Is there any way I can get that to say 1 minus cosine squared? Again, by subtracting cosine squared from both sides. Oh boy, having trouble writing. So if I want to, we have to decide, I can replace 1 minus cosine squared with sine squared. We think replacing my numerator with sine squared is a good option. Yeah, that seems like a really good option to me, too. So let's go do that. So it's sine squared. Right, that's what this turned into, right? Divided by sine of x. That's just my denominator. Again, you may notice there's more arrows than normal. That's because it's the recording, and so they can't see where I'm pointing. That's still really not one trig function. What does sine squared mean? It means sine times sine, and then I'm dividing by sine. Well, what if I told you it was, what if I told you it was x squared divided by x? You'd tell me it was x, right? This is sine squared divided by sine, so it's just sine, right? There's your one trig function. Because this one cancels with one of those. Ooh, better not put an x. That'd be bad. Just like over here on this one. This would cancel with one of those if that was the problem I gave you. So believe it or not, all of that up there is just sine of x. It's the same thing. Again, let's say I chose 60 degrees or something. I think we'd rather put it in sine of 60 degrees than in all of that. Okay? Do you have any questions?